Okay, so if you're deep in your GCSE computer science revision, you know there are certain questions that pop up again and again. And one of the biggest ones is about the CPU's fetch-execute cycle. In this quick explainer, we're going to crack open exactly what that is and, more importantly, how to write the perfect exam answer to guarantee you get those marks. And here it is, question 6A, straight from a recent OCR paper. It's only worth 2 marks, but come on, those are 2 marks you absolutely want in the bag. At its heart, this question is just asking you to describe the most fundamental job of the CPU. So what are the examiners really looking for? We're going to find out by looking at their own marks. But before we can read that perfect answer, we've got to actually get what's going on. The best way to think about the fetch-execute cycle is like the CPU's heartbeat. It's this constant, non-stop rhythm, this fundamental process that the CPU repeats over and over again to run every single program on your computer. So, what is the official definition? Well, it's pretty straightforward. It's the process of grabbing an instruction from memory, figuring out what it means, and then, well, doing it. Simple, right? But the real magic, and where you get the exam marks, is in the details of how that happens. Now, the easiest way to get your head around this whole thing is to break it down into 3 simple stages: fetch, decode, and execute. Seriously, just remembering these 3 words in this exact order is your first massive step toward building that flawless answer. Okay, let's dive into that first stage, fetch. The name kind of gives it away, right? In this step, the CPU's whole job is to go and get the next instruction it needs to work on. But for your exam, what does the official OCR mark scheme say you have to include? And there you have it, straight from the horse's mouth. To get that first point, you need to say that instructions are fetched from memory. And this right here is a golden exam tip. Being specific pays off. Just saying memory is okay, but saying RAM or primary storage is even better. It shows you know what you're talking about. So, how does that fetching bit actually work? I mean, the CPU doesn't just guess where to look. Nope. It uses a special little storage spot inside itself, called a register, to keep track of the exact memory address of the next instruction. It then takes that address, goes to RAM, copies the instruction, and brings it back inside the CPU for the next step. And that special register, it's got a name, of course. It's the program counter, or PC for short. Its only job, its whole purpose in life, is to hold the address of the very next instruction. As soon as that instruction is fetched, the PC immediately updates to point to the one after that. It's what keeps the whole show on the road. Okay, here's a top tip for you. For this specific 2-mark question, you probably don't need to name the program counter. But using precise terms like RAM and showing that you know about key components like the PC tells the examiner that you've got a really solid grasp of the topic. It's a great way to impress. Right, so the CPU has fetched the instruction from RAM. What's next? It's just a string of 1s and 0s at this point, which is basically gibberish. The CPU first has to understand what on earth it's just been told to do, and that brings us to the decode stage. And here it is, the next key phrase from the mark scheme. The instruction is decoded. All this means is that the CPU's control unit inspects the instruction and breaks it down to figure out 2 key things. What is the operation it needs to perform, and what data or memory location is involved? So this whole decoding job is handled by a very specific part of the CPU called the control unit. You can think of it as the manager or the director. It reads the instruction, the blueprint, and then gets all the other parts of the CPU lined up and ready for action. All right, we've fetched the instruction, we've decoded it to understand it, and now it's time for the main event. The execute stage is where the CPU finally gets to do the work. This is where the action happens. And look, the mark scheme skips it nice and simple for us. The instruction is executed or processed. That's it. This is the final step for this one instruction. The CPU just follows the command that it just finished decoding. So what does executing actually mean in practice? Well, if the instruction was a calculation, like adding 2 numbers together, another part of the CPU called the arithmetic logic unit, or ALU, swings into action. It does the math, and then the result of that calculation gets stored in yet another special register, often called the accumulator. Right, we've taken a tool through all 3 stages. We've seen the exact keywords the examiners have on their checklist. So, the big question is, how do we put it all together into a clear, concise answer that bags us both of those marks? This table just lays it out perfectly. On the left, you've got the key points from the mark scheme:
Fetch, decode, execute. And on the right, you've got a super simple way to phrase it in your answer. See how we're using those powerful, specific words like RAM and decoded? That's the key. And here you go, a beautiful model answer. It's short, it's to the point, and it hits every single nail on the head. It says the instruction is fetched from RAM, mentions it's stored in a register, and then clearly states it's decoded and executed. That answer right there would comfortably get you full marks. So, what's the one big thing to take away from all this? It's simple. Knowing the topic is only half the battle. Knowing the language of the mark scheme is your secret weapon. Using the exact terminology that examiners are looking for, fetch, decode, execute, RAM, is the most direct route to scoring those crucial marks. And that's a wrap. You are now totally ready to tackle any GCSE question on the fetch execute cycle. You've got this. So the only question left is, what part of the CPU are you going to master next? The ALU, registers, cache? Keep that momentum going. Thanks for tuning in.